Hey class, so today we will be using Rhino.Inside to parametrically influence a curtain wall panel. So this is a really good example of how to kind of take something purely Revit based, which we'll be creating in a bit, and then write a pretty much a pure Grasshopper script, and then combine the two to make it parametric and really leverage the power of Grasshopper with Rhino.Inside. So to start off, we'll have to make our curtain wall panel. So we'll hit new, new family, new family. Select the curtain wall panel, hit open. All right, and then we will toggle to the exterior view. So within the curtain wall panel, I don't think we've made one yet, but these reference planes are what will change and adapt the panel size to whatever grid layout you have within your curtain wall family. So, if you have 5x10 curtain wall grid, it will adapt and change to be 5x10. So we're going to build our model around it. So we're going to do just a simple extrusion and select the rectangle. We're just going to go from one corner to the other. And before we click off, see how there's these padlocks on each line? We're going to go around and just click those to be locked. And what this does is now these lines that build and create the extrusion will adapt and change based on the scale and the size of the curtain wall panel. And then before we click off that, what we're going to do is just going to offset this curve inside. So if you tab in, you can select all of them. Just like that. Doesn't matter the dimension right now as long as we make sure we have copy selected. And then we'll hit check. And now we have a hollow curtain wall panel. All right. So what we're going to be doing is utilizing Rhino.Inside to influence the opening size. So either we're going to want it super closed or super open. And to do that, we're going to set up some dimensional parameters. So I'm going to click and create some dimensions between the two sides. And then the top as well. Now, we're going to create two sets of parameters. One that influences the two widths, and then ones that influence the two heights, because depending on the size of the curtain wall panel, these dimensions may be different, and we want them to be proportionately the same. So let's see. Oh, and we will also need an overall width and overall height. So we'll do a dimension for the overall height and overall width. All right. Okay. So what we're going to do is we're going to create some parameters. So if we go up to our family types up here at the top left, we can go down and hit new parameter. So we'll do one for overall height. We'll want to make this an instance parameter. And we'll want this to be a reporting parameter. So because the overall width and height are going to be changing throughout, like I said, depending on your curtain wall family and the grid layout, it's going to be different sizes. So the reporting parameter just tells Revit and the family that these are going to fluctuate, and we are just utilizing this information to then influence our other parameters. So overall height, and create another one. Overall width. Do the same thing, instance and reporting parameter. And then we will set these. So up at the top, overall width, and then overall height. Okay. So after that, what we want to do is we want to set these offsets. So we're going to create a couple parameters. Let's see. So we're going to do the offset width. Make this an instance, but not a reporting parameter. All right, and then we're going to create an offset height. Instance, press OK. All right, and then we can just set these to 1 foot for right now. 1 foot. All right, and then we'll go and set these. So these two we will want to be the offset height, and then these two we will want to be the offset width. All right, so now once these change, they'll change together. So if we set them to 2 feet, they'll both be 2 feet, and so on and so forth. All right, and so what we can do now is we can go back into our families types window, and we can start to set up some formulas using one more parameter that we'll create to then influence and use basically the height to then influence the offset width. So we're going to do actually 2 new parameters. One is an offset factor. So this is what we will be using Rhino.Inside to influence. And so it's going to be an instance parameter. And instead of a length, it's just going to be a number parameter. Okay, so it's just going to be from 0 to 1. All right, so press OK. And then one more parameter, which is the offset override. So it might be a little confusing. So we're going to make it an instance, and we're also going to make it a number again. Now, what this one is going to do, so let's say we have this be 0.5. So the offset factor is going to be from 0 to 1. And basically, if it's 0, it's going to be fully closed. And if it's at 1, it's going to be fully open. Now, the problem with that is if it is at truly 0 and it's fully closed, the panel is probably going to error out because it has these 4 sides of the panel closing down and creating this really tight geometry here. And then the same thing happens if it goes all the way to 0 and is fully open. Then there's not going to be any geometry and it's just going to error out. So what we're going to do is use this offset override, and we're going to just do an if-then statement to to basically say if it gets below a certain point, it's just going to reset to a certain number, and if it gets up to a certain point, it's going to reset to a certain number, just so it doesn't reach that absolute 0 or absolute 1. So we're just going to start off if offset factor, offset factor is less than 0.01. Sorry, I'm reading. Then it is going to be 0.01. All right. So what this means is if this value, which is currently set at 0.5, but if this value ever gets below 0.01, it's going to just change it to 0.01. Okay. So if it's 0.0003, it's going to reset and just be 0.01. And that's just to make sure, if it does get down to absolute 0, it automatically resets and sets it to 0.01. All right. And then, so that's our minimum value. Now we're going to do if offset factor is greater than 0.99, and make sure that you put this 0 here, okay? Anytime you have a value less than 1, make sure that you put a 0 in front of it when you're writing these formulas. then it's going to be 0.99. And then comma offset, factor. And that is just saying that we want these. So basically, we want all of these formulas or all the numeric values that will result from this to then be attributed to offset factor. So you could create a completely new parameter and specify, offset whatever, and instead of resetting the offset factor value, it will actually reset whatever you type in here. So gonna just hit A and end those parentheses. And I think I might have missed one. Let's see. Sorry, of course with these formulas it's all very, oops. Oh, so my bad. So these are case sensitive. So let's make sure that the uppercase are actually uppercase. Oops, nope, that's an O. And I will pull this out at the end just so that you guys can read the full thing and pause it. Okay, there we go. So I thought it was the parentheses. So there's the full equation. So now if we try and set this to 0.00001, it's going to reset this to 0.01. And if this value is 0.00009, sorry, 0.99999, it's going to reset this to 0.99. All right, so this is what our script is going to be influencing, but this is going to be what is influencing our actual panel dimensions. So we're going to use this parameter within the equations here. All right, and these equations, so essentially what we want to do is utilize this number to multiply and manipulate the height to create a proportional value and proportional offset. So for the offset width, we're just going to say width divided by 2. So we're taking the overall width, overall width divided by 2. So we're taking the overall width, splitting it in half because we have 2 sides. And then we will multiply this by the offset override. All right, and then we're going to do the same thing. So we can literally just copy, paste this, but change it to height. Okay, so if we go here, see, so now our opening is very, very tiny. And then if we go in and change this guy to 0.01, apply, it's very, very large. And then if we just go straight down the middle, 0.5, it's going to be halfway. So now we have a proportional opening that we can influence. So the last thing that we will do is just create a thickness for this. So right now, if we select it, our extrusion end is at 1 foot and our start is at 0. We're just going to do -1 inch, +1 inch, and then we're going to set a parameter. So remember, this little very obscure gray button is what we use to set a parameter. We're going to hit new parameter, and then call this thickness positive, and this will remain a type parameter. And then this one we're going to associate as a thickness negative. Same thing, type. All right, and then in our family types, we're going to create one more parameter. Just call this panel thickness. Same thing, type. And we're going to, here, I'll show you so it actually does manipulate. So we're going to do 3 inches. Let me shrink this guy down again. 3 inches. And for our, I don't know why this keeps moving over like this. Okay, in any case, where is it? Here we go. So we're going to take the panel thickness, the overall thickness that we want. We're going to create one number that's half of it that's negative and one half that's positive. So we're going to take panel thickness divided by 2 and then multiply that number by -1. And then this one we're just going to do panel thickness divided by 2 to create a positive. Right? So that way we get I just went into the plan view. We get, depending on whatever we input for the overall thickness, it's going to evenly divide it on the center line and create that thickness. Okay? So there's all of our formulas. Make sure that you have it input correctly. And we'll go from there. So now that we have our full panel set up, obviously you could set material preferences and parameters, but for right now we won't do that. Sorry. So I'm going to save this. Go into a folder that you're using. And I'm just going to put adaptive panel family. Hit save. All right, and then I'm going to create a new project. So file, new project. I'm going to utilize our practice template. And then I'm going to go back to my panel. I'm going to load into the project and close. All right. And the only thing we got to do here before we open up Rhino.Inside is we're going to create a curtain wall panel. So we're just going to take a curtain wall family. We're going to edit the type. And where it says curtain panel, we're going to select our adaptive panel family. All right. And then for our layout, we'll do fixed number for both horizontal and vertical grids. So we'll drag this guy out and drag this guy up. Doesn't really matter. So dimensions in this script is not going to matter as much. What we want to do is set a high enough grid, a large enough grid, so that when we go in and place our image that we want our panels to mimic and reflect, it shows up. Because obviously the more panels you have, the more pixels essentially it will have to create that image. So I just did a 10 by 10. Obviously, if your computer is slower, more panels that you do, the longer it's going to take to crunch those numbers. So if it is a slower computer, maybe start off with a smaller grid and then work your way up. So now that we have that, we can go in and open up Rhino.Inside. So go over to your tab, hit Rhino.Inside, hit start. Let that think for a little bit. All right, so now that Rhino.Inside has engaged, we are just going to be working with Grasshopper today. So open up your Grasshopper window. All right, and we're going to start off with a fresh panel. I'm going to turn on bifocals so y'all can see exactly what I'm doing. All right, so now we got bifocals. So we're going to start off with a category component. All right, and we're going to right click and we are going to select our curtain wall panels. So curtain panels. Then we're going to do an element type picker. Plug this guy into the back and it automatically puts in our adaptive panel family. So that's perfect. That's the family that we're going to be influencing. Then we're going to use a type filter to use this family name to filter out all the instances within the project. And then we're going to query elements. Make sure that's plural. Query elements, put that in. And then at the bottom here, so they have actually integrated a limit to the amount of elements that you can query. You can increase that, however. So we're going to do that to 1,000 because right now we have 100, but we'll probably want to make that a little bit larger. Just be cognizant of that. I will say that when I first put together the script, I was not aware because this is a new component or a new input on Rhino.Inside version 1. So the first time I did it, I had more than 100 panels and it wasn't influencing the remainder, and that's why. So make sure you're cognizant of that limit quantity and go forward from there. So we'll use a element preview. Whoops. So we're going to take our elements and they're going to turn them into meshes. This is a little bit easier on your computer. So 121 panels. And then we are going to use the area component. So for you guys familiar with Grasshopper, our area component does one of two things. It takes the area of a piece of geometry, but it also gains the center of each geometry. So now we have the center point for all of our panels. And what we're going to use that for is we're going to patch over that to create a surface. So we're going to take our centroid, plug that into points, and I believe we need to flatten the points. So we're going to right click on points, hit flatten. Now we've created a patch. So we've created one larger surface through all of these different panels. The reason we're doing that is to then apply our image to, essentially. So create the patch and then we're going to do a surface closest point. So we're going to use those centroids again for a point and then plug in our patch. Okay, that creates our surface. And one thing that we're going to do here is we are going to reparameterize. Yes. What this does is, here, I'll do a panel so you can see it a little bit better. So if I undo this, well, this appears to already be reparameterized. But if it wasn't, what this does, it will essentially, I was hoping that it would give it a description. It essentially will reorient your UV coordinates of the surface from 0 to 1, right? So it could be from 0 to 10. It could be from 0 to 27. It really depends on the geometry and the surface that you're utilizing. But we just want to make sure that reparameterize is selected. So we get a UV point from 0 to 1. And for those And we've guessed it, this is part of what is going to be influencing our panel. So then after this, we're going to deconstruct point. So deconstruct a point. I'm going to plug these points in. And then we're going to remap. All right, sorry. First, we're going to hit bounds to find our minimum and maximum. What this does is it gives us the range of numbers. Let's see. Oh, and I need to flatten this out. So let's flatten these points. All right, now we got a nice even number. So this is from negative 48 to 31, and this is 14 to 14. Interesting. Ah, that's why. I need to unflatten this. And what I need to do is take this guy and plug it into that guy. That's what I needed. Sorry. So now we have the bounds. Again, we need to flatten this number, or flatten this list out, excuse me. So now we have a range 0.04 to 0.95, 0.04 to 0.95. It's a pretty good range. And then we need to remap the numbers from 0 to 1. So we're going to do copy and paste. We're going to create 2. All right, so we're going to take this range, the minimum and maximum, plug it into our source. Same thing here, plug it into our source. And then we're going to take this. These are our values that we are remapping. And then our target is already set from 0 to 1, but we could obviously change this. This is a pretty standard component for Grasshopper remapping and remapping a list. Basically, it's taking all these numbers. So let's say we don't, well, it's not going to matter, but let's say this list was from 10 to 207, right? So we're going to take all the numbers that are here from 10 to 207, and we're going to remap them proportionally so that they fit between 0 and 1. All right, so our lowest number, 10, is going to be 0, and our highest number, 207, is going to be 1. That's the same thing as doing here. It's only adjusting these numbers a little bit, but we're doing this to make it perfect. All right, so then we're going to construct points. Construct. I think it's point. Construct point. There we go. And then we're going to plug our remapped x into x, remapped y into y. All right, so now we have a grid of points, all from 0 to 1. And now we are going to use an image sampler. So image sampler, we're going to plug our points into the image sampler. This takes these points, plots them on the image, and then assigns a value to these points based on where they land on the image. So I have uploaded a gradient pattern to the canvas. I don't have it pulled up right now, but I will show you guys before you start tomorrow. So I'm going to of course it's not in So it's going to be this gradient pattern. Let's just open that guy up. Make sure to set it to color brightness. So we want it to be reading from white to black in the different ranges of gray. And then hit OK. All right, now we do a panel. You can see that each one of these points on the image now have a value between 0 and 1 associated with it. Now, for those who haven't caught on yet, we are going to use these values to influence the parameters we set up here. So our offset factor. We use these to then basically attribute each one of these numbers to the panel, individual panels, and then influence their openness to then match the gradient pattern we have here. So let's do this. Let us So before we do that, however, we are going to add a little bit more control to this depending on how our panels are reacting. So what we're going to do is we're going to create a value list. So a value list is something completely user determined. So it's going to give you a set of values in a drop-down menu that you can then attribute different values to. So we're going to do normal equals 0 and inverted equals 1. Okay, so we have, if we do the drop-down, we have normal and we have inverted. And if we plug our guy into there, we have 0, and then we select inverted. Our value is 1. What we're going to do this, we're going to take a subtraction component, plug this inverted into B, this guy into A, and what that will essentially do is for normal, it's the same exact, I'll copy paste this guy over. So on normal, it's just the same exact values, but if we invert it, it is basically the inverse, or whatever this value is minus 1, which will then give us, what this ultimately is doing is if our panels are closing at the gradient pattern, like let's say the panels are all closing in the black and opening at the white, what this component will do is essentially invert that and have it closing at the white and opening at the black. Okay, so I'll show you that once we get further along and finished what that actually does, but we'll switch that back to normal. Now, of course, when we do an inverted, it does create a negative. Now, we could just switch these two. So that 1 is always A, and then it's subtracting from B. But this is just a perfect chance to use another Grasshopper component called the absolute value, which takes any value, negative or positive, and gives the absolute value of it, which is positive. So then we'll take these values and then do a, where are you? And we're going to choose, we're going to utilize an element, parameter. There we go. Element parameter. I thought there was another title to it. But anyway, sorry, it's just element parameter. So what this is going to ask for is it's going to ask for the elements. It's going to ask for the parameter that we want to influence, and then the value in which we want to influence it. So we already had the values, so we can plug that in here. We also need the name of the parameter. So what we can do is, here's a shortcut for you guys. If you do 2 backslashes and then type in a word that you want to use. Oops. If you do double backslash, sorry, that automatically will create a panel from it. And then if you hit enter, don't click off, but if you hit enter, then it will input all of that for you. So you just don't, you can reduce your typing time by a little bit. All right, and then what we're going to do here, so instead of just plugging in our elements from back here, we're going to create a stream filter. What this does is it is going to automatically be at 0, and we can essentially flip this back and forth from 0 to 1. And so we're going to use a button. I think we used this last time as well, but our button will essentially either toggle between true or false or any other value that we deem fit. So right now you can see if I have it unpressed, it resets to the 0 input. And if I press it, it resets to the 1 input. So we're going to leave stream 0 empty. So it's always at a state in which it's not entering any information into the element parameter. And then we're going to take the elements from the query elements. This is all of the instances of these curtain panels. We're going to take and drag this guy over and put it into our stream 1, right? So what this is doing is it is preventing your script from running until you absolutely want it to. And it also will allow you to edit the curtain wall family without automatically updating. And it allows you to manipulate your script as much as you want and manipulate your Revit components as much as you want without having to worry about it constantly updating. It just adds a little bit more of a control to your script. So if we hit the button, it's going to think, because it is now applying 100 parameters to that. Now it's going to be yellow because it's reset back to 0, so it's not having any input into its element input, but it was for a brief second. So if we drag our screen down, or if we just minimize, our guy, and if we hide, if we open our script back up, there we go. If we highlight everything, hit Control Space, and then hit Disable Preview. All right, so now we have all of our panels reacting to the different gradients. All right. And let's say we change this from 10 out of 10 to 25, and let's say, I don't know, 17. Something weird. So now, if we go in, so this is updated a little bit, but if we go in and rerun our stream filter, it will update so it's a little bit cleaner and smoother. And then if we go in to split screen this really quick. So, created this normal versus inverted. So what this is going to do is, right now our white is fully open, our black is fully closed. If we rerun this, it's going to flip it. Right, so that just gives you a little bit more control when you're setting up these scripts. All right, see? All right, so that is the class for today. Setting up a pretty simple curtain panel family. Setting a couple pretty easy parameters. One kind of complicated if-then statement, but other than that, pretty easy, pretty simple parameters. And then writing a script, which is very simple. It's a relatively straightforward gradient script to then influence those panels and create a cool gradient parametric pattern.